Okay, so today we're going over trig, integrands, and substitution. Now when I say substitution, I actually mean U substitution, so I'm going to put like a little U over here that is supposed to be U. What letter is that? Okay, let me try to do this again. A U substitution. No, that still looks like a Y now. Ugh. Okay. U. Better. So I'm just giving you an example of one of the formulas. Now this formula cannot be used when n is equal to -1, okay? Now it's okay if n is like -1/3, but it's not okay if n is -1, because if we use this rule, then your exponent 0, and then you'd be dividing by 0, not good. So that's why we have the second rule, where it's the ln absolute value of u plus c, and don't forget the third rule, where it's working with e to the k x over k. So we have these examples where we're going to use u substitution. So let's get to it. Now for number 1, I'm going to rewrite my integrands as the quantity of 4x minus 1 to the 1/2 power dx. So in this particular case, I just said the quantity of 4x minus 1. So you want to make u the quantity that you describe. And then we find du. And this is going to be 4. In this case, we're going to write the dx. If you remember when we had to use the chain rule with the properties for FTC, okay, I didn't write it because we knew we needed to multiply, outside, inside. We always multiply with chain rule. But this time it's a little bit different. It's full-on substitution, okay? So let's see what we've got. We're going to rewrite our integrands as u to the 1/2 power, but I can't leave it as dx because the variables have to be the same. So that's where I have to write du. But, okay, I can't replace dx with du. I have to replace dx, let's solve for it, with 1/4 du. So I'm running out of space. So times 1/4 times du. Now if you remember my last lesson, it is a multiplication. So now I can use the properties and take out the 1/4, and that makes this a lot easier to work with, okay? Now hopefully you saw that we substituted the u and we substituted, with u, and we substituted the dx, and we were left with this expression here. We just kind of made it look nicer. Let me know if you have any issues. So now, when I integrate this, okay, I'm going to get 1/2 times the 1/4, so that's 1/6, u to the 3/2 power plus c. Now I have to actually replace the u back because I have to answer number 1, and that was in terms of x. So u being 4x minus 1, I now have my final answer. Okay, as we go through these will probably make more and more sense to you. So let me get to number 2. Again, if you missed something, make sure you pause the video and copy it down into your notebooks. This is not something you stare and don't do yourself. If you don't do it, you won't know it. Okay, so with this particular problem, my quantity is x plus 2. So I'm going to take the derivative on both sides. And now, this is just for the first part of our integrand. So I can have u to the 5th power du, but I'm going to split this into 2 integrands. So now I'm going to leave the other one just in terms of x. You could have done that before. I'm going to squeeze it in. So that way you can see how the u substitution is just on this side. And there we have it. So on the right-hand side, it's pretty simple, I think. So it's just the 1/2 x squared plus c, okay? Now on the left-hand side, we're going to have u to the 6 over 6. And you can write plus c here, but these two c's are going to add up to be a... You only need one of them. Let me get the eraser. Ta-da. So now we're just going to plug in the u, because we can't leave it in terms of u and x. We have to answer this question. And then we're done. So now we're up to number 3. And number 3, I'm rewriting it first as the quantity of 3x minus 1 to the negative first power with respect to x. Okay, so a couple of things here. N is negative 1, so we can't use this rule. We have to use that second rule that I gave you. And we also need to use substitution. This comes up more important when you see that it's not just x, like this is a 3x in my quantity. So I take the derivative on each side. This side is respect to x. And so now I'm rewriting my integrands. Now I can't write du. I'm jumping ahead. I have to solve for dx in order to replace it. So if I solve for dx, I'm dividing 3 on both sides. Oh, I ran out of space. Okay. I think I could squeeze it in over here. So divide by 3 on both sides. So then dx would be 1/3 du. All right. So times 1/3 times du. So I'm just going to rewrite this integrand. Okay, I'm going to take out the 1/3, and I really have du over u. And this is what I was saying was the second rule. It's the ln absolute value of, in this case, u plus c. So we're going to replace u again, so that it's in terms of x. And what color should I use? I think the blue would work nice. And that would now be our answer for number 3. Okay, so use substitution is very important. It doesn't just get rid of that 3. It doesn't go away. It gets involved in the problem. And that leaves with 1/3 in front of the ln. All right, number 4. So hopefully as you see these done, you're probably saying, okay, I'm seeing it, I'm not getting the hang of this. So you can always practice this by home and then check your work, check your answers. Don't just check an answer, because you can be guessing the answer and not really learning how to do the work. So be careful. Now this one's a little bit different looking, but you're going to use the properties, and I missed something really important because I was jumping ahead. I was too excited to break it up. What am I missing, guys? I was supposed to put dx here. You need the dx in order to evaluate an integral, because you have to say what it's in respect to. There's always that multiplication. Dx is actually like the change of x. It's like that width that we were doing when we looked at like Riemann sums and rectangles and stuff. Trapezoids even. All right. So on the right-hand side, this is a nice and easy one to evaluate. So it's going to be 5 halves x squared, I lost my halves, plus c. But on my right-hand side, I do need a u substitution. And it's going to be for my exponent of x squared, because it's not just like a kx or an x, it's x squared. So now I find that dx, okay, is du over 2x. I shouldn't get rid of the x, all right? Here's why. Because I'm going to have, let me get a different color here. Let's see, what color should work well? Blue. I'm going to have e to the u when I make u x squared. But I have to not only replace the dx, but I have to replace this x. Okay, just kind of remember you need to replace like all the x's somehow because you want it of the same variable. Like over here the variable was x, x, x. You can't have a combination of different variables. So I can't leave the x here. It's just not going to work. I have to replace both the x and dx. So if I need to substitute x and dx, I divide both sides by 2. So x dx is going to be replaced with a 1/2 du. I'm going to put the du over here. Remember, you're multiplying. And the e to the x squared is replaced with e to the u. Now you should see that this is something we can evaluate. So this is going to be 1/2 e to the u plus c, but we already have a c here, so you can erase one of them. Okay, don't forget to kind of bring this down. And my final answer is going to be 1/2 e to the u, which was x squared, plus, the rest of this, 5/2 x squared plus c. And that's number 4. So I went through different variations with these examples. Hopefully you get them. Let me know if you have any questions. Okay, so I'm giving you more formulas for your trig integrands. And sometimes they can be with kx as long as you divide by k, but we're going to use substitution, okay, to figure that out, all right? So copy down these formulas, start to memorize it with the other 3 that I gave you. And we're going to do number 1, so pause the video where you need. Okay, number 1. So it's not just the sign of x, it's the sign of x over 2. So u would be the x over 2, and du would be 1/2 dx. So for substitution, I'm going to keep this integral, I'm going to keep the sign, but I'm replacing x over 2 with u. I have to replace dx. So dx becomes 2 du. So we're going to take the 2 out. And so now I can use my formula to find that this is actually negative cosine of u plus c. You can put the plus c inside, but the plus c can also go outside. I went over that in yesterday's lesson. Don't forget, it actually has to be in terms of x if we're answering this problem, and a negative can go on the outside. What was the u? It was x over 2. Ta-da! Let's do a couple more, and then that's it. You should be good to go. That should actually be 2 and 3, but I think we're okay. You can follow along. So u in this case is 7x plus 5, so du would be 7 dx. So I'm replacing the angle measure with u, and I have to replace the dx, but it would be with 1/7 du. So take out the 1/7, use our rule for cosine, and we can't leave it as u. Oops, it should be u here, plus c. Okay, so the answer here is going to be 1/7 sine of 7x plus 5, the word sine, plus c. Okay, so let me know if you have questions on that, and let's do the last one. So in the last one, what we're going to do is rewrite this as the integral of secant squared of 2x dx. Before we do our u substitution, that's because we want to rewrite our fractions, just like we've done with other problems, No issue. So I'm replacing the angle measure with u, but I have to replace dx with 1/2 du. So take out the 1/2, and I wrote that a little sloppy, sorry. This is actually the tangent of u plus c. Let's replace u. And the answer for number 2 is 1/2 the tangent of 2x plus c. And that's it. You should be ready to go. Let me know if you have any questions. Good luck.